Hi guys. All right. Yesterday we did something like is 6x, and we said if x is 6, so f at 6 is 36. What does this f at 6 mean? Let's look at that. This was y, because y is equal to 6x is what? Is a line. Remember? It is a line. It is just a line. Y is equal to mx plus c, passes at 0, right? So now we are saying when x is 6, what is the y there? So that y is 36. Okay, so this is still linked with your straight lines and all the other functions. And we are saying it's a function because this is a function. So we are asking ourselves, this line is called a function, this line. But this line is defined by y. That's why we say y is equal to. Because in this function, you can only find this function when you apply your x there. I hope you do understand. Remember when we were doing graphs and we have to draw a table? So this is exactly what it means. So f at x is y, but y is dependent on x. That's why it's called f at x or f of x. Now, we are talking composite functions. Composite functions, it's a combination now of functions. So I've got f at x and I've got g at x. So it is the same as if here I had to put another line there. So there is one line which is a straight line and there is another which is a quadratic. So this one is f at x and this one I could call it g at x. It's just separation, it's just a name. G at x, f at x, all these are lines that are drawn here, or are functions that are drawn here, because this is still a line, but it's a line with a different shape. Parabola is still a line, but it's a different shape. And the straight line is still a line, but it's a different shape. So it's just it's defining. So you can't say f at x, and f at x. So it's just to differentiate them. Okay? So that's why we have g at x and f at x. All right then. Now this is what we have. These are the two that we have. Now we are saying this is composite now, because it's no longer f at x. It's f at g at 3. But you see here, now listen to me. The trick here is to start from the furthest on the right. All right? So now we are going to do that. So what is g at 3? What is g at 3? So let me substitute this 3 there. Yeah? Substitute this 3 there. So g at 3 is equal to 3 plus 5 is 8. Now, now it's f at what? At 8, which is 8 squared, 8 squared, 64. So that's your answer there, all right? Let's do a second one then. Now, I'm starting from the furthest. So I know what this is. Remember we did it yesterday? Yeah? You start from the furthest. G at minus 7. So what is g minus 7? So when you substitute x for minus 7, you are going to get minus 2, right? So g minus 7 is minus 7 plus 5. And then minus 2. Now you're going to take this minus 2 and substitute it into f. And f is x squared. So, right? Minus 2 is equal to, minus 2, 4. Okay? Now let's take this one. So this one is g at x. So like now, g at x, we don't have a number there. So we're just going to put it like this. So where there is x here, we put g at x. So let me just put f at x first. F at x is equal to x squared. But where there is x now, we put g at x, okay? So f at g at x, let me just rewrite this. F, I can write a big bracket there, at g at x, like that. So this will be like your f at x. So that will be your g at x, that will be x squared. So x plus 5 squared.